1 times negative 8 is negative 8, adds up to a negative 7. What? That's it. What two numbers can I multiply together that give me negative 8 that when I add them, I get negative 7? Angus, put your phone away. I'm taking it. Negative 8 and positive 1. So the top factors into x minus 8 times x plus 1. Okay. What about the denominator? 1 minus x squared. That's what kind of problem, Will? It's a dots. It's a difference of squares. 1 minus x and 1 plus x times, let's see, 3x minus 4x plus 1. So I'm going to do a times plus chart again. 3 times 1 is 3. Has to add up to negative 4. What two numbers can I multiply together to get a positive 3 that when I add them, I get a negative 4? Negative 1 and negative 3. So this one I have to factor by grouping. So 3x squared minus 3x minus 1x plus 1 over, how can I factor that 9x squared minus 1? You're right. Awesome. 3x minus 1, 3x plus 1. Okay, so this has to get factored by grouping. So I'm going to group these together. Let's see. If I group these terms together, what's the greatest common factor I can pull out of that first grouping? A 3x. And that'll leave me with x minus 1. What's the next greatest common factor, like for the next grouping? A negative 1, and that leaves me with x minus 1. So here's what this is going to look like. X minus 8 times x plus 1 over 1 minus x times 1 plus x times, my numerator is now, grab your copycat, x minus 1 times what's left over, 3x minus 1. And the denominator is 3x minus 1 times 3x plus 1. So we can reduce from top to bottom, right? We learned that when we simplified fractions or simplified rational expressions. We can reduce from top to bottom, and we can reduce from side, like top to the opposite. Will you shut off that front light and see if you guys can see the board better? Perfect. Thank you so much. So, what do you want to get rid of first? 3x minus 1 and a 3x minus 1. I totally agree. What else can I get rid of? X plus 1 and what? If I get rid of an x plus 1 and a 1 plus x, that was our lesson on Friday. What happens? I have to put a negative. I'm just going to put a negative 1 right there. Do you guys see anything else that I can do? X minus 1 and 1 minus x. If I do that, that means I need another what? Another negative 1. Okay, what is a negative 1 divided by a negative 1? A positive 1. So these cancel each other out. Do you guys see that? So what do I have left in the numerator? X minus 8 over, what do I have left in the denominator? 3x plus 1. Okay. That's it. I want to talk to you about it. And this kind of lends itself back to your homework that we did, the pages 3 and 4, which I didn't ask if you guys had any questions. I'll go back to that in a few minutes. So the last problem of your page 3-4 homework asked you guys had to fill out that table. And when x was 2, you got an error in your calculator. Do you guys remember why that happened? Look at page 4. When x was 2, why did you get that error message? Any ideas? Yeah, when you plug that 2 in, you get a 0. That's why it gave us that weird error, because we know that we can't have what in the denominator? We cannot have 0 in the denominator. So let's look at, I want everyone to look at the original numbers in the denominator, and we're going to talk about excluded values. When we say excluded values, these are numbers that x cannot equal. So let's see, x cannot equal, because if it equals this, it would give us a 0 in the denominator. So what value can x not be here? 1 minus what gives me 0? Yeah, x can't be 1. Okay, what value here would give me a 0? So can I write it as plus or minus 1? Is that okay? So I can't have a positive 1 or a negative 1. That would give me a 0 in the denominator. What about this? Well, let's think about how we learn to factor. We learn to solve by taking the factors and setting them equal to 0. Do you guys remember that? So if I were to do that, I would end up with adding 1 to both sides. And I get that 3x equals 1. Divide by 3. So x cannot equal 1/3. But if I look at the other factor, 3x plus 1 equals 0, and I subtract 1 from both sides, I get that 3x equals negative 1. Divide by 3 means that x cannot be positive or negative 1/3. These are excluded values. We're going to try to talk about every single time we simplify a rational expression, we're going to identify the excluded values, because that's going to help you when we start graphing. Okay, that's going to help you when we start graphing these. Got it? Okay, can we do the next one? Is anyone still writing that down? Go ahead. So question B. So it's really important. Remember, I said this when we learned factoring. I said, you're going to have to pretty much know how to factor to get through this. You're going to have to know how to factor to get through this. So while Mackenzie's finishing that up, I want to read that note. So under multiplication, it just says factor all the numerators and denominators and then reduce. Get rid of common factors and cancel out. Cross-canceling is allowed. But under division, what does it say first to do? If you look at your little flow chart, under division, it says change what? Change multiplication by multiplying by the reciprocal. So that's the first thing that we're going to do. So here's my problem. And the first thing that I need to do is change this to multiplication. And I do that by multiplying by the reciprocal. So I have x squared minus 6x plus 8 over 3x to the fourth minus 6x cubed. That part does not change, but the reciprocal, I'm going to multiply by the reciprocal of this. What does it mean to turn that into its reciprocal? I'm just doing what? I'm just flipping it upside down. The reciprocal of 3 is 1/3. 3 over 1, you just stand it on its head. So the denominator gets moved to the top. So that's now 2x cubed minus x squared divided by, times 4x squared minus 1. So this is what we're going to do. We're changing that division to a multiplication. So now we have to factor or find some GCFs. So can we factor that first expression? That looks a lot like our warm-up. Almost exactly like our warm-up. What's this factor out to? That's what we did in our warm-up today. Yeah. X minus 2 times x minus 4. What about the denominator? Do I have a GCF in there? 3 what, Chris? Open your eyes. 3 what? Well, look, what's the smallest power of x over there? X cubed. So that means I can take out a 3x cubed from both of those. So if I divide this term by 3x cubed, I'm just going to be left with an x. If I divide this term by 3x cubed, I'm going to be left with a -2, right? So now let's go to the other side. What can I take out of the numerator? Zach C. What can I take out of the numerator? Yeah, I can divide both of those by x squared or pull an x squared out. So if I divide by x squared here, I'm going to be left with a 2x. If I divide by x squared here, I'm going to be left with a 1. Okay. What about the denominator? What kind of problem is the denominator? Is this a perfect square? Yeah. Is this a perfect square? Yeah. So this is a difference of 2 squares. How do we factor those? 2x plus 1 times 2x minus 1. Because there's no b term in the middle, right? And that's because when we factor these or FOIL these out, this turns into a positive 2x, this turns into a negative 2x, and they cancel each other out. Those are called conjugates, okay? They're called conjugates. So let's look at simplifying. Do you guys see anything that I can cancel out from the top to bottom? 2x minus 1 in the numerator and in the denominator. Yeah. X minus 2. I agree. What else? Ladies, close your Chromebooks. Close them up. Close them up. What else can I take out? An x squared. Yeah, if I take the x squared out of here, what do I have left down here? Just a 3x. Yep. Anything else you guys see? So let's see. In the numerator, we multiply straight across. So the only thing that's left in the numerator is x minus 4. In the denominator, we multiply straight across. I have 3x times the quantity 2x plus 1. Okay. So let's talk about excluded values. What are the values that x cannot be? X cannot equal, even though we crossed it off, what value here? What value is that? 2. X cannot be 2. Okay. What about these two? It's going to be a plus or minus. Plus or minus. When I solve that, 2x plus 1 equals 0. Subtract 1. It gives me 2x equals -1, or x equals -1/2. And because the other sign is the opposite, that would be a plus or a minus 1/2. What else can x not equal? We're just looking at zeros in the denominator. What's that value? It would give you a root of 0. We struggled with that when we did unit 3. If I just pull an x out, that just means that x can't be what? 0. So my excluded values are 2, positive and -1/2, and 0. Because if I let x equal 0, 3 times 0 times everything else is 0. Do you guys see how that works? Yay or nay? Some of you have this face like I'm thinking about it. X minus 4. If I let x equal 0, 3 times 0 times 2 to the 0 plus 1. Well, anything times 0 is what? Are we allowed to have a 0 in the denominator? No, we are not. Okay. Does that make sense? Okay. Who's still writing that down? Raise your hand if you still need that up there. Okay, example C. It says it's your turn, but we're going to do it together because, again, these are your notes. So let's see. I have x squared plus 2x minus 8 all over 8x minus 16. And when I see a division problem, I automatically change it to multiply and reciprocate the last fraction. So I'm going to say times 2x plus 10 over x squared minus 16. Do you guys see what I did when I was writing my problem down? Open your eyes. Chris, Eliza, do you guys need to stand up? You can go to that table right over there. Open your eyes. Come on. So what can I take out of the numerator of the first fraction? Numerator of the first fraction, what can get factored out? Any ideas? Positive 4, negative 2? Let's see. I agree. X plus 4 times x minus 2. Good job. What about the denominator? What can I take out of the denominator? Yeah, I can take out an 8, a GCF of 8. That leaves me with x minus 2. What can I take out of the numerator from the fraction on the right? A 2. And what does that leave me with? X plus 5. And x squared minus 16. Connor, how does that factor? Perfect. X plus 4, x minus 4. Okay, what are some things that we can get rid of? Anyone? X plus 4. Yep, cross reduce. What else? X minus 2. Anything else? The 2 will go into 8 4 times. Okay. We multiply fractions straight across. So the only thing that I have left in my numerator is x plus 5. The only thing I have left in my denominator is 4 times the quantity x minus 4. Okay. Let's talk about some excluded values. Let's see. X cannot be what are some things that x can't be? 2. X cannot equal 2. Good job. What else? Plus or minus 4, yeah. Did we pull an x out in the denominator? Did we pull an x out of anything? Nope. So that's just it. X can't equal 2 or plus or minus 4. Those are my excluded values. I'm pretty sure I did not get rid of that. I'm going to check really fast. I think that I tried to graph that. I want to show you really fast how to identify maybe excluded values. I'll go back to that note in a second, but I want to show you something. So can I put that problem up there? So let's see. Y equals, we have a division problem. So my numerator was x squared plus 2x minus 8. And my denominator was 8x minus 16. And then this whole thing is going to get divided by, let's see, it's getting divided by x squared minus 16, which is divided by 2x plus 10. So I want to show you what happened. So we said our excluded values were when x is 2. So I'm going to go to when x is 2 and I'm going to touch my graph. What does it say there? Undefined. It's really cool that Desmos does that for you. Tells you that that's excluded, right? What about positive 4 and negative 4? What happens when I go to negative 4? Undefined. What happens when I go to positive 4? I'm going to have to go like way down here. What is this going to do? What's this creating? Do you guys remember? An asymptote, right? We talked about vertical, horizontal, and vertical asymptotes when we did exponential functions. And if I were to go up to the top, it's going to do the same thing. It makes a line going in the opposite direction. So positive and negative 4. It's never going to get to negative 4. It's going to get really, really close. And it's never going to get to positive 4. It's just going to get really, really close. Does that make sense? It's never going to go 4.000. It's just going to be really, really close. Okay. So that's just, I wanted to show you that you can kind of check your holes or your excluded values by clicking on that. Okay. So I'm going to